Hello, Mr. Allman here, and this is your Allmancast on the basics of data processing. Once you have summarized all of your quantitative data in a raw data table, it's necessary to be able to take some simple steps in order to be able to combine this data to make it better suited for analysis. There are two things that you're going to commonly do. Take averages in order to combine together the results of individual trials, and then secondly, find the spread of that data using standard deviation. Those are the two things I want to show you in this video. Now, while your data table might be present in a Google Doc, the math that you need to do is going to be simplified greatly if you can use spreadsheet software like Google Sheets to be able to do those calculations for you. So the first thing I'm going to do is to copy this data over into an open new blank Google Sheets and paste that data in from my Google Doc. The formatting might change, but that doesn't matter. We're really just using Google Sheets as a temporary holder for the information and a place to be able to do the math. So in order to take averages, really what I mean here is I want to combine together what the results were for any repetitions that I had. If I measured here percent O2 concentration at 0 seconds 5 times at the temperature of 15 degrees Celsius, I want to know what was the average O2 concentration at that point, and then what was the average O2 concentration for every 30 seconds later. So Google Sheets or Excel or a similar spreadsheet software will do that math very quickly and easily so that you don't have to spend all that time on a calculator. I'm going to add into this row the average O2 concentration for that particular temperature. So in order to do this, I need to use a common spreadsheet functionality called a function. So in the box where I want to display that particular value, I want to start with an equal sign. That equal sign then needs to be followed by the function that I want the spreadsheet software to carry out. In this case, I want it to compute an average. So I'm going to start typing in average, and what you'll see is that Google Docs will make a suggestion based on the type of data, or you can just simply select using the drop-down list the function that you want. Now, in this case, it's suggesting that I take an average of B4 to B8. And that's actually exactly what I want. But for the sake of this video, I'm going to show you how to do that manually. So here I've selected average, and then I have the beginning of a parentheses. Those parentheses need to be followed by the boxes that I want it to take the average of. So I'm going to left click and hold down all of the boxes that I want it to average. And then once I've selected the correct boxes, I'm going to hit the enter key. And then in that box, it now gives me the average percent oxygen concentration at 0 seconds. Now, rather than having to redo that same process again and again, I'm going to highlight the cell in which I computed the average. I'm going to go to the lower right-hand corner, and the little cross cursor is going to appear. And I'm going to click and hold and drag that all the way across horizontally to get to the end of my row. So that you can see, I'm going to highlight this in yellow. And so what you can see now is that all of those yellow boxes are the average O2 concentration of the 5 repetitions that I had measured above. So when I start to do analysis, I no longer will be looking at individual trials, but rather I'm going to be doing just those average trials based upon the combined totals from that particular temperature. So I'm going to then repeat that process then for my other temperatures. All right, now you can see that I filled in the rest of the averages for all of my other data. Next, I want to compute the standard deviation. The standard deviation is a common tool that's used as a common statistical tool that's used to be able to find what the spread of the data is. In other words, if you see inconsistent measurements at a particular setting, you're going to find that the standard deviation will be greater in size. And a greater standard deviation means that there's a little bit more variation, and thus that might call into question a little bit more the results of your experiment. Conversely, if all of your measurements at a particular setting are very similar to each other, that shows that there is a very low spread in the data, and because there's less variation, there's a smaller standard deviation, and that means you can be more confident in the results at that particular setting. In order to compute standard deviation with our spreadsheet software, again, I want to, just like with the average, I want to insert another row because the standard deviation will be different for each data measurement that I took. So I'm going to insert another row below my average. And in this box, again, I'm going to label this. So standard deviation for the average percent O2 concentration at 15 degrees. I'm going to hit the equal sign, which will bring up again the possibility to add a new function. And I'm going to write in ST because I know that standard deviation, and here I have already a suggestion of standard deviation for B11 to B15. That's not what I want. I actually want standard deviation for the boxes above. So I'm just going to choose the regular standard deviation function. And I'm going to highlight again the boxes that I wanted to take the standard deviation of. Notice I'm not using the standard deviation including the average. I'm only taking the standard deviation of my individual measurements. I'm then going to hit enter, and it calculates the standard deviation as 0.1. I then will go to the lower right-hand corner. When that little crosshairs comes up, I'm going to click and drag that all the way across through my last reading, and I will then get a calculation of standard deviation at all of my other time periods. I'm then going to repeat that process for my other independent variable settings. Once I've calculated all the standard deviations, now I have a set of information that might be relevant for me to be able to put into a new data table in the data processing section of my lab report. In that section, I would want to include all of those averages and standard deviations that I had calculated. Now, one important thing to note about using spreadsheet software is that the spreadsheet software is doing math, but I'm working with measurements here. And as you can see, all of my measurements have the percent O2 concentration calculated to 3 sig figs. Now, when the average is taken of those, sometimes it's going to report additional values. For example, here, 20.34. Now, I wouldn't want to put that 20.34 into my a data table in my lab report because this really should be rounded to 3 significant figures, and I should report this as 20.3. So just make sure to go back and do that rounding when you actually copy this over back into your actual lab report. Or you can investigate the various ways in which Google Sheets will allow you to be able to automatically do that rounding for you. The same thing would be true of standard deviation. Instead of this long decimal number, I would want to shorten that to 3 significant figures and be able to report that based upon significant figures in my lab report. Now, one final thing that I want to show you is that you need to consider other ways in which you might need to be doing some simple processing. In this case, if I'm doing rate, my calculation of rate is really dependent upon change over time. And so in this case, I have a change in percent oxygen concentration over a given period of time. So if I have an initial and a final percent O2 concentration, I should really calculate what is the change in percent oxygen concentration. And instead of doing that for each individual repetition, instead I can simply find that difference across my averages because the average is really what I'm concerned with. So now I'm going to go and I'm going to start a new column here, and this is going to be the average change in percent O2 concentration. So here again I can use a function, and that function in this case is going to be minus. You can always look up these functions. An easy way is to just go to open a new tab and to search in Google for what the name of a function is if you're not sure what you're looking for. In this case, I know that there is a function called minus, and so I'm going to select that minus function. I want to do final minus initial, so I'm first going to click the final box at 180 seconds. Then I'm going to hit a comma because I want to subtract the initial box B from that. So now this function is minus H9 minus B9. So that's going to be checking again the final O2 concentration at 3 minutes minus the initial O2 concentration. Once I have the function that I want, I'll hit enter, and now it calculates that average change in percent O2, which is a negative 0.12. So now that's telling me that there is a drop in 3 minutes of 0.12% oxygen concentration. I want to repeat that process. I'm going to copy that same function and paste it down. Now, one of the things that you'll notice is that what Google has done is that it's automatically changed the boxes so that instead of using the items from row 9, it's now using the items from row 16. And so I'm getting a different result corresponding to the values that are present in that row. So I'll go ahead and continue to copy that down so that I can get my average changes in percent O2. So once I have the difference in O2, now that needs to be divided by the amount of time. Now I could divide this by the number of seconds, but I'm going to start getting into very small decimal numbers, which are hard to really be able to make comparisons of once there's a lot of decimal places. So what I'm going to do is I'm going to find now the rate of change in O2 concentration over 3 minutes. So I'm going to go down to, again, the spot next to my average change in O2 concentration. I'm going to start a new function, so I start with the equal sign. And in this case, I want to divide. So I'm going to start with div. I'll check to make sure that I have the divide function that comes up. And now what I want to do is divide what's in box I, here that negative 0.12. Then I'll hit the comma. I want to divide that not by another box, but I want to divide it just by a number. I want to divide it by 3 minutes so that I'm going to get the change in O2 per minute. So I hit enter without hitting my number, so that's a good example of what happens if you don't enter in the formula correctly. So I'm going to put 3 in there, the number 3, and I'm going to hit enter. So notice you can always change the function. It's always displayed up here at the top in this bar. So now this number is giving me the rate of change in O2. I wrote here over 3 minutes, but what this really means is per minute. So now this is an actual rate, negative 0.04% per minute. That's the actual decrease in oxygen over time. Again, I'm going to copy that function and then paste down to be able to find what my other rates are. So now I have negative 0.04, negative 0.09, negative 0.11, negative 0.16, and negative 0.18. So again, these are numbers that could then be displayed in another table. So I could draw a new table in my lab report where I could report these calculations. It's very normal to use spreadsheet software to do the math for you. What you can do is in your lab report include a short annotation describing how it is that you did those actual calculations. So in this case, I could say that I found the average of the percent O2 concentration using Google Sheets, calculated the standard deviation using the same spreadsheet software, and then calculated the average change by taking the final O2 concentration minus the initial, and then dividing that by 3 minutes to get a rate of O2 concentration drop per minute. So a few simple sentences describing what I did along with the actual numbers themselves will be sufficient to be able to show not only what the final result is, but show the process that you went through in being able to actually calculate it. Thanks for watching.